There we go. So yesterday we talked about, right, mixed and improper fractions a little bit. We talked about how to convert a mixed to an improper, noting the fact that, right, your denominator stays, and then it's 3 times 2 plus 1 kind of thing. But it kind of revolves around that denominator. We talked about integers as well, right? That was the previous page. So integers, one thing to remember is, right, if you have two signs that are the same, right, equal signs always turn into a positive when they're next to each other. Opposite signs always turn into a negative when they're next to each other. And so we kind of talked about that a little bit. If you have two integers that have opposite signs, then you would have to subtract them and take the sign of the biggest number. If they both have the same sign, then that sign follows all the way through and you just add those values up. So we started adding fractions. So fractions with different denominators, you need a lowest common denominator. If you don't find the lowest, it's just going to be a bit more work at the end reducing the fraction. Okay, because that's what we want. We always want a reduced fraction at the end. Okay, so let's keep going here. B, 2/3 minus 5/8. 2/3 minus subtract 5/8. And you need to find the lowest common denominator. So a number, it could be one of the ones that is already present, but it's a number where both of them fit into. Oftentimes just multiplying the two will get you there. So the lowest in this case would be 24. Okay, so your lowest is 24. So you basically rewrite both of them out of 24. Okay, and then you basically ask yourself, what did you have to multiply 3 by to get the 24? Well, you'd have to multiply it by 8, okay, to get there. So there'd be 8 times 2 would be 16, right? You basically do the same thing with the numerator, or else it ceases to be the same fraction, right? 8 goes in there 3 times, therefore 3 times 5 is 15. So now you have them both out of the same denominator, and you get 1/24. So you just, when it's adding and subtracting, it's only the numerators that get added or subtracted, right? So there's that. C, 2 1/9 minus 1 1/3. The first step there is convert to an improper. Okay, so let's go ahead and do that. So it's going to be out of 9 when we convert it. So it's 9 times 2, which is 18, plus 1 is 19. Okay, minus, this one is going to be out of 3. So it's 3 times 1 plus 1, that would be 4. Now you realize you need a lowest common denominator. And in this case, it actually happens to be one of the numbers that is already there. So you write it out of 9. This is 19 out of 9. Nothing changes. Minus, you're going to write the thirds out of 9. So you had to multiply this by 3 to get to 9. So you have to do the same thing with the numerator to get there. Okay. 19 minus 12 is 7/9. Okay, so that's that. Some teachers will vary on the notation, so you just have to follow it. There are teachers, like, let's go back up to B, they would have that, and then below you write it there, so they want you to have an equal sign, so saying this line is equal to this line is equal to that final answer. So you have this line is equal to this, right? and that is equal to all of this. And some would say, hey, put the answer underneath. I'm not a big stickler with that because it's still accurate to say that this is equal to that. But some teachers don't want more than one equal sign per line. So if you want to be correct, and now some of you are probably upset that you're gonna have to erase, right? So that would be the proper format. So maybe I will stick to that just to be on the same page here. Are we good? Okay. Let's go over to this side. So I'm going to use this column here. So we have D, which is negative 4 halves minus 3 2/3. I'll figure that out. And then we're going to do some multiplying and dividing. So we need to convert to improper. So this line would be, this is halves, right? 2 minus 4, right? So you have to be careful, like this sign here, I will tell you what to do with that sign. It follows this fraction. So just put this sign in front of it and then forget it. When you're converting, forget about it. It's 2 times 4 plus 1, right? So that's 9, negative 9 halves. So this fraction turns into negative 9 halves. And then you go minus. This will be out of 3, right? So 3 times 3 is 9 plus 2 is 11. So my next line would be, I need an LCD. What's the LCD here? 6, right? 6 it is. So write this out of 6. That's going to be a negative minus out of 6. So you needed to multiply this by 3 to get the 6. So therefore you have to multiply the top by 3 as well. 3 times 2 would give you 6. So you have to multiply the top by 2 as well. And here you have both of them are negative. So you're just going to add these up, right? And know that your final answer is a negatives because you're adding negatives in a sense. Okay, so that would be 49. 49 over 6. If you need to reduce it, go for it, but you can't in this case. Okay. E 2/3 times, sometimes there's a dot, it doesn't matter, depends on the textbook, times 5 over 8. So in to make this easier later on and to save you from having a harder time reducing, we reduce right away, right? That's what when I put at the top, when I say cancel first, then multiply across, what that means is you're looking, it's like, okay, these are both even here, right? I know that 2 goes into 2 one time. So you kind of cross that 2 out and just say 1. And 2 goes into 8 4 times. Right? So you've divided both of these, even though they're from different fractions, when they're multiplying, only when they're multiplying, can you do this? Okay? So now it's basically 1/3 times 5 over 4. Okay? So you've reduced it to that. And then you multiply across. So you go 1 times 5 is 5. 3 times 4 is 12. Okay. So cancel first, right? Cancel first. And if it could have been that these two could also have had common factors, right? Like that there's a number that goes into both of them. In this case, there was nothing in common there, so you just leave it, okay? So you try to cancel as much as possible before moving on. F here, we have -3 1/5 multiplied by 2 3/4. Again, when you have mixed numbers, improper, convert to improper first, okay? So we're gonna go, right, 5 times 3 is 15, plus 1 is 16, so it's be -16/5 times. This one is gonna be out of 4, I know that, right? 4 times 2 is 8, plus 3 is 11. And we will cross simplify, right? So what we're going to do here is, so this is still, by the way, this is still the same thing as up here, right? Two fractions are multiplying, except for you have brackets around both of them. Okay, that's still, they're multiplying. So can cross simplify, right? You can tell that the 4 goes in here one time, and the 4 goes in here 4 times, right? Does that make sense what I'm doing there? Because essentially they're going to be part of the same fraction. So you're already simplifying before you get to the end. Okay. So 4 goes into both of them. It goes in here once. It goes in here 4 times. Then you check across here. There's nothing you can do there. Okay. So then your next line would be -4 times 11 would be -44. 5 times 1 is just 5. I always get the negative to float up to the numerator. It doesn't matter if it's in front or the top or the bottom, but don't put negatives on both of them because then the whole thing turns positive, which is wrong, right? So that's what we're doing there. I'll keep going on a different page here. Maybe I will add here a little note, cross simplify. 16 and 4 can both be divided by 4. That's all I'm going to say there for that. In case you're looking back, it's like, how did that happen again? What happened there, right? FG Okay, good. Next, G. 2/17 times 9 and 1/3. And then we're going to do some division. Okay. They're both mixed numbers. You want to convert them to improper fractions. So this is going to be out of 7. This is going to be out of 3. 7 times 2 is 14, plus 1 is 15. 9 times 3, right? 3 times 9 is 27, plus 1 is 28. No need for an LCD when you're multiplying or dividing, okay? You cross simplify if possible, right? 3 and 15, you can tell that the 3 goes into both of them. So 3 goes in here once, 3 goes in here 5 times. So you cross-reference like this, and now we're going to cross-reference like this. You see a common factor. Common factor is the same thing as a number that goes into both of them. 7 goes into both of these, correct? That's where our mental math skills come in, right? Goes in here 4 times, goes in here 1 time. Right, so it's 5 times 4 is 20. 1 times 1 is just 1, so we just leave it at 20. Right, no need to. Okay, so let's say you didn't do the crossing out. Let's say you just go 5 times 28, 7 times 3. It's just going to be harder to simplify later on. Okay, that's why I'm doing that. It's a lot easier to work with small numbers than working with the final product, right? Okay, let's do some division here. 4 over 7 divided by 2 over 5. So when you have a division, you multiply the first times the reciprocal of the second. Reciprocal is a fancy word for a flipped version of that fraction. Okay, so 5 over 2. It has to be the second. You cannot do that with the first. It has to be the second. So we'll just reciprocal. Because you're going to see that word again. So I need you to know what that is. Okay. So this line is the same as this line. And let's see if we can cross. It turned into multiplication essentially, right? 2 goes into 4 2 times, goes in here 1 time. So really it's now a simplified version. So it's 2 times 5 is 10. 7 times 1 is 7. That's what it is. I negative 3 1/2 divided by 4 and 2/3. So we're going to leave some room there. Give that one a try, okay, on your own. Pause here for a bit. And I will give you a really one that combines them all. We'll do that one together. I will do I in a bit. I'm just looking at the answers you were giving there. And again, if this is something you're very comfortable with, if you're going ahead of me a little bit, that's fine. Just watch for the little things, okay? So we have a lot of things happening. We have two brackets, and those are being divided. Within each bracket, there are there are operations happening there. So we're just going to focus on each bracket first, and then we're going to address the operation that's between the two brackets, right? So here we need an LCD, right? And the LCD there is 28. So we're going to write both of them out of 28. 4 goes into 28 7 times, so it's 3 times 7. 7 goes into 28 4 times, so it's 1 times 4. We'll keep this in brackets like this. And we subtract that and we get 17 over 28 like that. So equals, right? So we're going to do one line at a time. We're slowly going to break this down. So we took care of the first bracket. Now I'm going to add to my work working with that second bracket. The first thing I need to do here is we need to convert this to mixed numbers, right? So we can do that here. So this would be a negative first of all, right? Don't forget negatives, they're extremely important, okay? 2 times 1 is 2 plus 1 is 3, so it'd be negative 3 halves minus 7 times 1, which is 7 plus 2 is 9 over 7. Okay, so I have to do a little bit more work with this one. Now I can do an LCD here, and the LCD in that case would be 14, right? 14 fits both of them. So I'll keep this in brackets like this, make both of them out of 14. Right? 2 goes into 14 7 times. Don't forget the negative, right? 2 goes into 14 7 times, so 7 times 3 is 21. 7 goes into 14 twice, so it's 2 times 9 is 18. Okay? So as long as you show your work, you'll be fine. Okay? So this division follows, and I'm going to find out what this is. They're both negative, so I'm going to add them. I'm going to add and keep the negative though, right? Like this. So there I am at 39, right? And this is now turned into a division, right? So we can first of all say that 17 over 28, right? Multiply negative 14 over 39. Like you flip this like that. And before you're going to multiply, reduce, right? I don't know if you see that, but this is 28, right? And 14, you can actually see that 14 goes into 28, right? So use that. 14 goes into 14 once. 14 goes into 28 twice. And a lot of times you will see that the numbers work out quite nicely. And I'm going to use this to just tell you that there are no calculators for the first two chapters. Okay, so chapters 3 and 4, no calculators for any of the work. So that means that we need to keep the numbers reasonable, right? So that's your advantage there. Anyway, so now let's figure this out. Let's see if I'm going to have room there. So it's 17 times negative 1, that's negative 17. And this is 2 times 39, which is 78, right? And notice that I brought the negative up here to the 14. I find that when it's in the middle, students don't know, does it affect both the 39 and the 14? It's better to, I always say it floats up, because the numerator being negative still makes the whole fraction negative. But then at least you know that it's only going to show up here when you multiply 17 by 14 and not again. Otherwise you get a negative and a negative, turning the whole thing into a positive. You don't want that. And now to reveal the I, right? I is negative 3 over 4. Yeah. So I'm just going to work that out. Some of you are still writing this down. So this would be, converting this, right, it would be negative 7 over 2 divided by, right, so is equal to, this would be 12 and 14 over 3, like that. The next line would be negative 7 over 2 multiplied 3 over 14. Right, at this point you realize, oh, 7 goes into both of these. 7 goes in there once, goes in here twice, right? And then your next line is negative 3, right? Negative 1 times 3 and 2 times 2, which is 4. So that's your final answer, negative 3 over 4. Okay, so I will now direct you towards the fraction handout that I gave you, and I'll show you what it looks like. So those of you who haven't come through here yet, I will post it for you. Let me just find it. It looks like this. You're going to get a paper copy, so don't print it, okay? It looks like this. And if you're going to take a screenshot now, do that. What I will do is I'll give you some time, but I will start equations towards the end, the last 10 or 15 minutes, okay? So maybe be strategic right now. Just do, I'm going to do an addition and subtraction, maybe a couple of harder ones. I'm going to do a few multiplication and then a few division, and then leave the rest for homework, okay? But I'm giving you some class time to do your homework. How's that, okay? And then I'm going to go over these tomorrow. I'll give you the answers to them, or maybe even later today. I might post them later today. So if you see something posted, it'll be the key to this worksheet so you know you're on the right track. Okay? So work on this for now. The solution to an equation is the value of the variable. The value of the variable that makes the equation true. And I'm just going to say, in a nutshell, right, the left-hand side of the equation will be equal to the right-hand side of the equation. Okay? That's when an equation is true, when both sides are equal to each other and they amount to the same thing, right? Remember, that when a term changes sides, we flip the sign. Okay, that's very important. In order to solve for a variable, comma, we use inverse operations. So what does that mean, right? There's addition, right, and subtraction, right? So those are opposite. There's multiplication, and its inverse would be division. Okay. So examples. A 4y minus 8 is equal to 12. And normally what I try to do is, right, the goal is to isolate the variable. That's the ultimate goal for us, right? You want to have whatever variables there are, you want to try to bring them all to one side and make it so that there's nothing around it. So you just want the coefficient of 1 in front of it. Okay, that's basically your ultimate goal here when you're trying to solve an equation. So I see that 4y is on the left side. There are no y's on the right side, so that step is already taken care of. There's no y that I need to bring over to here. But there's something multiplying y and something subtracting from it. You need to take care of this first. Okay. So what we do is we bring the 8 over. So the next line would be 4y is equal to, the 12 is already on the right hand side. The 8 comes over adding. I'm going to use a different color here for it. Right? It came over adding to that equation on the right side. And then you end up with 4y is equal to 20. Right? And at this point, you want to do the inverse of what's happening to y, which is multiplication. So you're going to divide both sides by that coefficient. The coefficient is the number that's in front of a variable, right? And then you end up with y is equal to 5. And notice that there's only one equal sign per line of my work, right? So you start with an equation, you always keep an equation. Before this, I gave you expressions, and so every line was equal to the next, equal to the next, equal to the next, so the equal sign was on the left, right? So there's that. So to check your work. I don't require this on a test or something, but you should be able to check. So if you go, we determine that y is equal to 5. So if we plug that in, 4 times 5 minus 8 is equal to 12. 4 times 5 is 20, minus 8 is equal to 12. This is 12 is equal to 12. So we know we're correct. Okay, you substitute y in to that original equation. B, 5x minus 3 is equal to 8x plus 6. So the variables can change. It could be z, m, and o. O is a bad one because you mix it up with 0, right? But it could be. So here, you notice that you have a variable on either side, correct? I like to bring everything over to the left, like the variable, I like that to come over to the left, and all the numbers that are like, these are called constants. Like if they're just a number on its own, I bring all the numbers over to the right side. So the next line goes like this. So whatever changes sign, I'm going to use a different color for. The 8x comes over here subtracting. So whenever you cross the equal sign, the sign changes for you. Okay? Is equal to. The 6 is already on this side. The 3 comes over adding. Like so. Okay? So you can, I know teachers taught you differently, and I'm not too picky as long as you're consistent, right? As long as it's mathematically sound. Some teachers taught you to just add 3 here and go minus 8x here, like right on the beginning. That's fine. I might actually do that later on, but right now I'm just showing you exactly what's happening. So 5x, now you're going to combine your x's, right? 5x minus 8x, that'd be minus, sorry, 3x, right? That'd be minus 3x. So 5 minus 8 is negative 3, and there's negative 3x is equal to 9. Now you're going to divide. Now the inverse operation of multiplication is division. So we're going to divide by negative 3, divide by negative 3. Right? And so x is equal to negative 3, right? Because the 3 goes into 9 3 times, and it's negative 3 there. Okay? Make sure you want to get rid of any negatives. So if this is negative, you divide both sides by a negative. And this is a positive divided by negative, which will turn the whole thing negative. C, let's go with this one here. Something like that. 5 over 4x minus 3 is equal to 7. I just want to tell you this. A teacher can never cover all possible scenarios. So you kind of have, what we're trying to get you to see is like, what's the pattern? How do I work around it, right? So this 5 over 4x minus 3 is equal to 7 could have been on the right side, and the 7 could have been on the left side. So don't be too fixated with it has to always look like this. It's the same thing, okay? Nothing changes. Okay, so I have a fraction as a coefficient in front of x. That is kind of, they're glued together. Don't do anything with it just yet. Focus on the constant, okay? This 4 is only affecting x, not the whole thing. I'll show you what happens when the 4 is affecting the whole thing. So we go plus 3 on the other side, right? So 5 over 4x is equal to 7. It's already there. And the 3 comes over adding like that. So that's 5 over 4x is equal to 10. And now you need to deal with this one at a time. I usually deal with the denominator first. So I'm going to multiply this by 4 on this side, and I'm going to do the same thing to the other side. Right? And so what happens here is these two cancel out like that. So you end up with 5x is equal to 10 times 4 is 40. And now you deal with the 5 that's multiplying. You divide by 5. You divide by 5. And x is equal to 8. There we go. Does that make sense, folks? Yeah? If it's a little different, That's fine, right? Math is in that sense uh, a universal language, right? Because it can be done different ways. So I'm not too picky if you do it a different way, really, as long as it's mathematically sound. If you're watching your notation and stuff like that. Okay, D. Let's do this one here. -2 brackets times x plus 6, and then there's 3 times 4x minus 1. Trying to see. Yeah, I think you're gonna be okay. There's one case that I won't cover, but oh, you can't even see that. Sorry, guys. There it is. My bad. Out of bounds. So let's get this done hopefully before the bell rings. You've got a coefficient in front of a bracket, right? So this is affecting both terms in there. So you got to distribute. You remember that? It affects everything in that bracket. So -2 times x is -2x. -2 times +6 is -12. 3 times 4x is 12x. 3 times -1 is -3. I'm not going to use a different color now, but I'm going to bring all the x's over to the left and all the constants over to the right. So that will give me -2x. The 12 is positive on that side, comes over subtracting. Equals. The 3 is already there, I'll leave its sign. The 12 comes over adding, like so. Combine them, they're both negative, so you're adding negatives. So it's -14x is equal to opposite signs, but you know it's going to be positive. It's going to be +9, right? And then we divide both sides by -14. Okay, this goes to just x, and this, I bring the negative up, is just that. Perfect timing. So listen to this.